Haven't started yet.
Sorry.
Okay, good evening everyone. So I hope everyone had a good day today. So this one is our last session of our NMOS live stream. Alright, so this is Teacher Chiu from Ting Academy.
Wait for people to come first.
Alright, we have around 5 people right now, so maybe I'll introduce introduce myself again later. Alright, so I hope everyone is doing well. I hope everyone had their dinner. Alright, okay, so we're still waiting. We'll start at 8. Alright, we'll start at 8 sharp. Alright, so how's everyone? I hope everyone is doing well. Alright, gentle reminder, NMOS is in 1 month. 1 month time. Maybe 1.5 months, not really 1 month. So make sure to just prep yourselves, right, with our book A. And we are going to go through maybe around 5 more questions again. This time around, these questions over here, majority of questions are very similar. So that's why I decided to pick the 5 questions today. And we are going to go through some very, very important concepts that you guys might need to keep in mind about. Right, so this one is for your primary 4 and primary 5 students. Alright, for those who are taking Math Olympiad. So you'll be surprised, alright? So you read this particular question a little bit more carefully, you realize that this one isn't really for P2, alright? Yeah, so alright, so it's a little bit higher level. We are expecting this one to be maybe a P4 or P5 level, alright? So we have already we are around 9 viewers right now. So we are just going to let more viewers come in. We are going to just sit back a little bit, relax a little bit. We will start at 8. All right. Alright, so we are seeing a little bit more people now. How's everyone doing? Alright, so welcome to our third and the last live stream for our book A. Teacher Chiu over here. So hopefully everyone had a good dinner. And well, we'll start at 8. We'll start at 8 sharp. So it's around 7:58 now. So we are going to let more people come over first before we begin. Alright? Okay, good. So I hope everyone is doing well today. So we have quite a large influx of students coming in. Alright, quite a lot of viewers coming in. Alright, so good evening everyone. We will begin in around 2 minutes, alright? Alright, so these questions are actually from our NMOS book, alright, NMOS preparation book. It was the redemption period is already over, unfortunately. So what we can do this one, our main target audience is actually for those parents who have redeemed this book quite a while ago, right? So we are at our last live stream now for this particular book. So what we can look at over here in this case, is really what you can do is to really look at the questions and learn the important concepts from it. Alright, good. So it's about time, alright, 8 p.m. already. Thanks everyone for coming over. Alright, so really happy to be able to see everyone. This is Teacher Chu speaking from Think Academy. Alright, 6 years of teacher experience in PSLE, O levels, and A levels. So feel free to hit me up or DM Think Academy, our webpage over here, and I'll handle over here, and we will get back to you. Alright, so Think Academy basically specializes in primary school mathematics, alright, Math Olympiad, and your standard PSLE MOE syllabus. Alright, so something that you guys can keep in mind about. Alright, so feel free to DM us for more information. Okay, good. So without further ado, let us move on to our third live stream. Alright, for our NMOS competition preparation. So this one is our live stream 3 now. Alright, so pardon me for the two particular dots over here. I think it's a little bit of printing issues. Alright, but it doesn't really affect the quality of the questions. Right, the question is just going to be the same. So let's take a look at this particular question. Right, the following figure is a road map. Alright, with the values marked on each section of the road indicating the number of minutes it takes for Amy to walk this section of the road. Right, find the minimum time in minutes, alright, for Amy to travel from A to B. Right, so the question is very simple. Alright, we are given this particular map over here, and we need to find the shortest time for Amy to travel from A to B. That's it. But what's the difficult part about this question? What's so difficult? Well, we can really just guess it out. We can kind of start from the smallest value, etc., and move on from there. But what's the challenge over here? Well, the actual challenge over here is this. Alright, so let's take a look over here. All these are particular numbers over here. And there are lots of possible combinations, right? There are lots of possible combinations. And in this case over here, it might not be very wise to actually write out all these particular combinations and find the one with the shortest time. So we need to have some plan for it. Well, in this case over here, we have some students who have learned this particular thing called the shortest path, right? Will be able to understand this. Now, think about it. From this case over here, let's take a look. From A to travel to this particular point, how long will it take? What are some possibilities? Right, in this case over here, how long will it take to travel from A to this particular point? Well, in the most straightforward sense, it will just be 5 minutes. Right, 5 minutes. Right, is there any other paths that will lead to a shorter time? No, definitely not. Right, so you can see that you can travel from here all the way to here, but you're going to spend more than 5 minutes over here. Right, you're going to spend a total of 7 plus 1, you're going to get 8 minutes, right, which is more than 5 minutes. So you're better off going in a straight line over here. So the shortest time taken is 5 minutes over here. So I'm going to write this as 5. Now what's next? Well, when you look over here, right, from A to here, how long will it take to travel to here? Well, 4 minutes, right, that will be the fastest. So we're going to label it down. Right, 4 minutes. Now, so this is the idea that we're going to go at. Right, we're going to look at every single possible point. We're going to find the shortest time it takes to travel there from A. That's the idea. And of course, naturally, we need to compare times, alright? You will see what I mean in a while. So let's take a look at this, alright? So in this case, A to this particular point over here. In our travel from A to this particular point over here, there are two short ways in that sense, alright? There are two short ways. We can go in two roads. We can travel them in two roads. The lesser the number of roads, the shorter time you will take. So in this case, we can travel by here to here, alright? Which will take up 4 plus 3 minutes, which is 7 minutes. Or alternatively, you can travel from here to here, and then travel upwards to here, which will take a total of 6 minutes. So which route is faster? Well, you can immediately see that this route is going to be faster, and hence we will take 6 minutes, alright, the minimum time taken will be 6 minutes in our travel from A to this particular point over here. That's ideal, and we are going to indicate it with a 6 over here. So you can see a particular pattern that is forming, alright? So let's do a little bit more, alright? Let's do a little bit more. Well, in this case, what about this point? Well, in this case over here, this point is pretty straightforward. You just need to travel 5 and 3, and you get pretty much 8 over here. Now, what about points like, for example, this one? This one is a little bit more difficult, alright? But in this case over here, we can use our previous points over here to actually find out how long will it take to travel from here to here. Alright, these points over here, they are very useful for us. They tell us how long will it take to travel from A to here. So in this case over here, we can actually travel to this particular point from this way. Or we can actually travel to this particular point from this way. So if you notice, if you are over here, you already spend 6 minutes. And in order to travel to here, you need to spend an additional 5 minutes, which will add up to 11 minutes, right, to travel from point A to here. But alternatively, if you are here, you already spent 8 minutes. And in order to reach here, you need to spend 4 more minutes. Alright, so in total, you're going to spend 12 minutes from here to reach here. So you will notice this one is 11 minutes, and this one is 12 minutes. So that's why over here, we are just going to take 11 minutes over here, because that is the faster route. Right? So same argument goes for here. Alright, 4 minutes to travel this long line over here, and 6 minutes, so total is going to be 10 minutes over here. So in this case, we can take a look at this one over here. Now in this case over here, we have 10, 8 minutes, 18 to reach here. Oh, we have 6 and a 10 over here. It will take 16 minutes to reach here. So which one is the shorter route? The shorter route is going to be the 16-minute one. Alright, and then afterwards, what's next? Alright, you guys notice, hey, we are almost at the end. So 16, 2 more minutes to travel to a B. Or you already spent 11 minutes here, 8 more minutes to travel to the B. Well, definitely the 18 minutes one, because this one is 19 minutes. Alright, so that's why the shortest time taken, alright, the shortest time is equal to 18 minutes. And that's the idea. Alright, now you notice for those students who have done some math Olympiad over here, alright, especially the P4 and the P5 students, you guys will realize this is actually a variation of the shortest path problem. Alright, in our shortest path, we have this very simple problem over here. Alright, we have this very simple problem over here. In the shortest path problem, we have a cube. Alright, cut into maybe 9 squares. Alright, and then you need to travel from A to B. Right? How many ways are there to travel from A to B through these 9 squares over here, through the edges of these 9 squares over here? Well, remember, so some of you guys will know the labeling method. In this case, you take 1. There's one way to go from A to here. So one way from A to here. There's also one way from A to here. One way from A to here. One way from A to here. And one way from A to here. Now, afterwards, what do you do next? Well, you pretty much add up the values preceding them, right? Get the new values at the edges, at the points over here. So 1 plus 1, you're going to get 2. Right, 2 plus 1, you're going to get 3. And then 3 plus 1, you're going to get 4. Alright, we're going to repeat this method. We're going to obtain a 3. We are going to obtain a 6. And we are going to obtain a 10 over here. Right, we are going to obtain a 4. We are going to obtain a 10. And finally, we know that there are a total of 20 ways. Alright, 20 ways to travel from A to B. That is essentially the idea over here. So in order to find the number of ways to travel from A to B, we can add them up recursively. We can look at the preceding values and we just simply add them up. So this question over here is a slight variation of this shortest path problem in the sense that this time around, the distance is actually time. Right? You can view it as time over here. So that you can view the distance between the edges this time around is viewed as time. What is the time taken to travel? And you definitely want to find the minimum time taken to reach the particular point. Alright, so very similar, alright, very similar. And if you are able to understand the shortest path, you should also be able to implement this concept and idea onto this kind of questions. Alright, I hope this one is clear. Alright, so very good. Now let me move on to the next question for the day. Okay, this particular question over here. So let's take a look at this question. Alright, we have 10 machines, alright, in warehouse A. 10 machines in warehouse A. And 6 in warehouse B. Alright, these machines are to be relocated in factory 1 and 2. 11 to be sent to factory 1 and the others to factory 2. So there's a total of 60 machines over here. Alright, there's a total of 60 machines. Alright, 11 of them are to be sent to factory 1. So 5 machines to B. To 2. Alright, so that's something that you need to keep in mind about, alright, especially when the question doesn't give very numerical information. You might want to convert it into numbers to make it a little bit clearer. So let's take a look. The unit cost of transporting one machine is shown below, alright? You need a unit cost, alright, every unit. How much does it cost? So how do we interpret this table? How do we read this table? Now in this case over here for warehouse A, alright, we want to deliver this machine from warehouse A to factory 1. This is going to cost you $5 per unit of machine. Alright, so this one is all per machine prices. Alright, so something you guys need to keep in mind about per machine prices. Right, something that you guys should take note about. Now, per machine prices, so one machine, warehouse A to factory 1, $5. Warehouse A to factory 2, $6. Warehouse B to factory 1, $7. Warehouse B to factory 2, $10. Alright, we want to find the minimum cost in dollar for the transportation. Alright, so we have to find the minimum transportation cost needed. Alright, minimum transportation cost to deliver all the machines to their respective factories. Well, so how do we tackle this kind of questions over here? Well, this is where the assumption method comes in. Alright, the assumption method is going to be very, very helpful when it comes to this kind of questions. Well, in this case over here, let us think about it. Alright, what's the cheapest option? What's the cheapest option? Well, you can see that the cheapest option, right, in this case, is this. From warehouse A to factory 1. Alright, so we are going to focus on this guy. Warehouse A to factory 1. So, in this case over here, we know that factory 1 requires 11 machines. And we have 10 machines in warehouse A. So, we are going to put all 10 of our machines in A. All of them needs to be sent to factory 1. But remember, we need 11 factories away, we need 11 machines to be sent to factory 1. So we need one of them from B to be sent to 1 as well. So you don't get 11 of them. And then we are left with 5 machines in warehouse B. 5 machines in warehouse B. So the last 5 of them must go to factory 2. So what's the total cost for this particular transportation? Well, it really becomes a multiplication problem, right? Multiplication and addition problem over here. The total cost in this case, right? Alright, so we have 10 machines from warehouse A to 1, alright, and cost $5. So it's going to be 50. Oh, B. One machine B, alright, one from B to factory 1, it's going to be just $7. And then what about this? We have 5 machines from warehouse B to factory 2. Alright, this is going to be $10 each. It's going to be $50. Right, this one will be $107 in total. Well, would that be the final answer? Well, in this case over here, it doesn't seem like it is the final answer. I mean, they have given us a lot of other information that we didn't consider. So, if you look at it a little bit carefully, there might be other answers over here. But how do we get this particular answer? Now, if you look carefully, in a way or another, you think about it. It costs us $10 to transport a machine from warehouse B to factory 2. Right, it costs us $10 over here. And if you look at it closely, if I were to deliver 10 machines from warehouse A to factory 1, it costs me $5. Right? Why not I try to increase some? Why not if I try to allocate some of the machines from warehouse A to factory 2 instead? Right? So you can start off with 1. Right? Will it decrease? Well, because it just costs that $6, maybe I save a little bit of that. But I'm not sure. Right? I'm not sure. Maybe I want to do something about this. So I'm going to try it out. So in this case over here, let's take a look at this. Maybe I have 9 machines from warehouse A to 1. Factory 1. And the last machine from warehouse A will head over to factory 2. Now what about the other 6 machines? Well, we definitely need 2 machines to go to factory 1. And we need 4 machines from B to 2 as well. So what's the total cost for this one over here in this case? Well, the total cost over here, pretty straightforward. We have 9 A's, alright, to factory 1. This one will be $5 each. It's going to be $45. And then we have 1 A to factory 2, which will cost $6. We have 2 B's, alright, to factory 1, which will be $14. And finally, we have 4 from warehouse B to factory 2, which will be $40 in total. So in this case, all we really have to do is to really add them up. This is really 45 plus 20. 6 plus 14 is 20, so 65. Add 40, we're going to get 105. Alright, so the cost over here is going to be 105 instead. So now you look carefully, hey, the prices, the total cost actually decreased. Right, namely because the reasoning is like this. Right, we actually decreased the number of machines traveling from warehouse B to 2. Right, so this gives you another very big hit. Hey, what if I try to remove as much as I can? I do not rely on machines from warehouse B to factory 2 anymore. So this one is we can try out, and then we are going to see what is the cheapest possible cost. So let's try out. So we need 5, alright, we need 5 machines to factory 2. So we're just going to draw them from warehouse A. So in this case over here, we have 5 machines from A to warehouse 1, factory 1, and 5 machines from A to factory 2. Alright, we are going to fulfill the need of factory 2 first. Alright, then what's next? Alright, we have 6. Alright, we have 6 in warehouse. We have 6 of them in warehouse B. So in this case over here, we have warehouse B over here. We are going to deliver all of them to factory 1. Alright, 6 B delivered to factory 1. Alright, now our question over here, as usual. What's the total cost? What's the total cost? Well, let's take a look. So total cost over here. Alright, we know that 5 machines from A to 1 is going to be $5 each. It's going to be $25. Alright, and then we have 5 A's from 5 machines from warehouse A to factory 2. Alright, each of them is going to be $6. It's going to be $30. And lastly, we have 6 from warehouse B to 1. Right? So 6 of them, 6 multiplied by $7 each, it's going to be 42. Alright, so adding them up, we actually get a nice answer of $97. Alright, so that is the essential idea. Now the reasoning is really like this. You notice that warehouse B to factory 2 is too expensive. And by doing other routes, we actually save on the cost. Alright, and that is the reason why it decreased, where we try to remove the possibility of having machines delivered from warehouse B all the way to factory 2. So that is the crucial idea when we are dealing with this question. I hope everyone is clear. Alright, do not just look around and then try to get some particular combination, because you will not be sure. Right, so in this case over here, you might want to apply the assumption method. Right, go for the cheapest possible rate and see what happens, and then see what you can do with it afterwards. Right, that's another very important concept when it comes to this particular question. Alright, I hope this one is clear. Now, let's move on to the next question for the night. So, let's take a look at this particular question. So, we are going to divide 135 people into several groups and require that the number of people in any two groups be different. Alright, so find the maximum number of groups that can be divided into, and we can divide them into. So how do we work on this question? Well, if you think about it over here, right, in order to find the maximum number of groups, there must be a group with just one person. Right, there must be another group with 2 persons, because you can't have groups with the same number, because total maximum groups in this case, without any restriction, is going to be 135 itself. It's going to be 135 itself. So in this case over here, that's not possible, because we require the number of people in the groups to be different. And 135 groups, having 135 groups won't necessarily mean that in each group there's only one person. Alright, so how do we go about it? Well, in this case over here, we can start off with one group, 1 person, the second group, 2 persons, third group, 3 persons. Well, it doesn't interfere, right? The group's numbers are different. Right, we start with the smallest and then we gradually go up. And this will assure us that we have the maximum possible number of groups. So we might want to grab a calculator, and then we'll start typing. Alright, we'll start typing. Alright, but that is with a calculator. Alright, it's going to be very easy with a calculator. But hey, we are not allowed to use a calculator in this math Olympiad competitions, right? So in this case over here, how do we work on this particular question? Well, we can try to let the number of groups be n. Maximum number of groups. Right? That's essentially the idea. We're going to let n represent the maximum number of groups. Well, in this case over here, we want n to be as close, alright? We want this particular n to be as big as possible, while making sure this thing, alright? 1 plus 2 plus 3 plus 4 plus all the way to n is equal to 135. Right? That's the idea. Now, in this case over here, how do we work on this particular question? Well, you look at it, we have 1 plus 2 plus 3 plus 4 all the way to plus n. Well, does someone remember the formula for this particular expression? Well, you do remember, good. Alright, so you don't remember, it's also a good time to go and remember it. 1 plus 2 plus 3 plus 4 all the way to plus n has a very nice formula over here. In this case, it will be n multiplied by n plus 1 divided by 2, which is equal to 135. Right? So like for example, if you have 1 plus 2 plus 3 plus 4 plus 5, right? How to find the sum quickly? Well, you can take 5 times 6 divided by 2, right? And you get 15. So you want to find larger numbers, you also can use this particular formula as well. Right? So that's something that I assume a lot of you guys would know already by now. Now, let's talk a little bit more. So in this case over here, I'm going to multiply 2 on both sides. I will multiply 2 on both sides. And we are going to obtain 270. Right? So n multiplied by n plus 1 is going to give us 270. Well, how are we going to work on this question over here then? Looks a little bit difficult for us to work on, right? So because this one is a quadratic, alright, and of course I'm not going to go through all the quadratic stuff, right? We are not going to talk about the quadratic formula, the complete the square. I mean, this is a primary school math Olympiad competition, right? So we're going to do this concept. We are going to use this idea of approximation to try and estimate the value of n. Alright, you guys need to keep in mind that n does not necessarily need to be, when you get this particular value of n, when you multiply this number with n plus 1, it does not necessarily need to be equal to 270. Right, it can be lesser than that because remember we are forming groups. That's the idea behind this. So you guys notice n multiplied by n plus 1. Right? This is actually roughly just n squared. Alright, which is just n times n. Think about it. 20 times 21. It's just roughly the same as 20 times 20. Right? This one becomes even more true when you talk about a little bit bigger numbers over here, like 99 times 100. It's going to be roughly 99 times 99. Right? What's the point of doing all this approximation over here? Well, it's going to simplify a lot of things. It's going to make our guesses better. So in this case over here, what about this one? 270. Well, there's an n squared over here. There's an n squared over here. So what we're going to do is, we're going to look for a perfect square that 270 is closest to. Right? What's 270? 270 is probably close to 225. Which is equal to 15 square. Right? This one would result in you making a guess. Hey, maybe n is equal to 15. Maybe n is equal to 15. So let's take a look at n equal to 15 in this case. Right? N equal to 15. Alright, so we are going to obtain 15 times 16 divided by 2 is going to give us 120. Alright, that's good, It's well within our range of 135. Alright, so you take one group, 1, the second group, 2 people, third group, 3 people, all the way to 15 groups, 15 people. We are going to use 120 people. Now, there might be a possibility that, hey, maybe we can add another group that is different. So let's take a look at n equals 16. Right? What about n equals 16? Well, we have 16 times 17 divided by 2. Which will give us 136. Which is more than 135. So this one is impossible, right? Therefore, this one will allow us to immediately conclude this, to make a conclusion over here, that the maximum number of groups, right, maximum number of groups is equal to 15. Alright, how do we distribute? Alright, we have 120 over here, so we are left with 15. And each of them, we can actually increase them by 1. So maybe one group can have 2 people, the second group have 3 people, all the way to the last group, maybe it can have 16 people. So we are kind of distributing them over again to get the final answer of 135. Right? That is essentially the concept behind this question. Alright? So the concept of approximation is very useful. Now, keep in mind, for primary 4 and primary 5 students, you do not necessarily need to know how to solve a quadratic equation. Alright? You guys will know quadratic equations are only probably basically taught in Sec 2. Alright, we will learn the basic factorization method. And when we move on to Sec 3, we will do the completing the square, we do a graphical method, and we will do quadratic formula. Alright, so these are very high level methods, alright, that we won't actually teach in the we won't actually test in the NMOS competition. Alright, because after all, this is for primary 4 and primary 5 math Olympiad. Alright, so something for everyone to keep in mind about. Alright, now let me move on to the next question for the day. Okay, so let us take a look at this particular question. Now, it looks very straightforward. What is the remainder when 16 to the power of 61 is divided by 7? Well, in this case over here, like what I mentioned to everyone, alright, we do not necessarily need to know the concept of modular arithmetic to solve these kind of questions. We do not need to necessarily know this particular concept in order to solve these kind of questions. Most of these kind of questions, especially in NMOS, is going to give you some pattern, alright? And the whole idea is to start small. Now, how do we start small in this case? Now, let's take a look at this, alright? 16 to the power of 61 divided by 7. What's the remainder? Well, in this case over here, the first thing I want everyone to keep in mind about is this. Alright? 16 power of 61 is equal to 14 plus 2 to the power of 61. Right? That is essentially the idea over here. And the 14 component, right? The 14 component is always divisible by 7. Right? 14 is always divisible by 7. Alright? So, remainder of 16 to the power of 61 is going to be the same as 2 to the power of 61 when divided by 7. Right? So this comment looks a little bit slipshod at the start. Right? But there is valid grounds for this particular statement over here. Alright? And the concept that we are actually looking at over here, the more abstract concept that we are actually looking over here is called the binomial theorem. Right? Where you can actually expand this one. Alright? And you realize that the only thing that is not a multiple of 14 is 2 to the power of 61. Right? So some of you guys will heard this thing called the binomial theorem, right? So we are not going to talk too much about this, right? But binomial theorem allows us to expand this kind of things over here. And we'll notice that the only thing that is not divisible by 7, or rather has a might have a remainder, is really just 2 to the power of 61. So that's why in this case over here, 16 to the power of 61, when it's divided by 7, it's going to have the same remainder when 2 to the power of 61 is divided by 7. That's the idea that I want to bring everyone about for this particular question. Alright, so it simplifies a lot of things. Now, so let's take a look at this particular question again. So, we are going to start small. What do I mean by start small? Well, 2 to the power of 61 divided by 7 might be too big. Right, we're going to start a little bit smaller. Let's take a look at 2, alright? 2 divided by 7. Alright, this one is going to give me something. I don't really need to know the something, I just need to know the remainder. 2. Right, that's the idea. And what about 2 to the power 2 divided by 7? Right, it's going to give me something again. Alright, maybe something. Maybe 0. Alright, remainder of 4. Alright, now, what about 2 cubed? Which is 2 times 2 times 2, divided by 7. Well, which is really 8 divided by 7. I get a remainder of 1. Right, now, we don't really see any pattern yet, so let's continue. 2 to the power 4 divided by 7. Alright, now this one is going to be just 16. 16 divided by 7, alright, will give us a remainder of 2. How about 2 to the power 5? 2 to the power 5 divided by 7 over here. 2 to the power 5 is we say 2 divided by 7. Alright, is going to give us a remainder of 4. Alright, I hope everyone can see that there's some sort of pattern, but if you guys can see, it's okay. We can do it one more time. 2 to the power 6 divided by 7. Alright, 64. Alright, this one is going to give us a remainder 1. Hey, looks like there's some sort of pattern that's going on over here, right? It goes in this particular pattern. 2, 4, 1, 2, 4, 1, 2, 4, 1. It goes in groups of 3, alright? There's always a groups of 3. That's the idea behind this, right? It always goes in groups of 3. And so naturally you can think about it, 61, alright? We look at 61 over here. Right, when we divide it by 3, right, this one is going to give us 20 groups, remainder 2. 1, sorry, remainder 1. And where does this correspond to? Alright, this one over here is going to be the 61st group, or aka the first group over here. So that's why, alright, 2 to the power 61 divided by 7 is going to give me something. I don't need to know the something. There's definitely no need to know, because at the end of the day, all I want is the remainder. So what's the remainder over here? Well, it goes in remainder 1 over here, so remainder of 2. Alright, so essentially the remainder is just going to be 2. And if you think about it, that is essentially the idea that I would like to bring everyone about over here. So there are some times where we can simplify these kind of questions over here. And one really important thing is through this. Alright, 16 to the power 61 is a multiple of 7 plus the remainder. Alright, you're going to simplify the number. You're going to simplify, lower down the values over here to make it easier to calculate the values. Otherwise, you're going to deal with powers of 16, which is very, very difficult in my opinion. Right, something for everyone to keep in mind about. Alright, so some of you guys might also have different ways, alright, because you guys will notice that 16 is really just 2 to the power 4. Alright, that also works as well. Right, that also works as well. As long as you reduce the base, you will be able to see these kind of patterns much more easily as compared to others. So the remainder, to conclude, is just equal to 2. Right, that is the crucial idea to this particular question. Alright, so I hope everyone can understand where am I going, and I hope it is clear enough for everyone to catch. Alright, good. So let's move on to our last question for the day. Right, for our live stream. Alright, the last live stream question for the day. So it's another remainder question. It's another remainder problem. So what is this time around? Well, it looks a little bit more complex, right? So we're going to find the last digit. I'll find the last digit of 2008 cube minus 2007 cube plus 2006 cube minus 2005 cube all the way to 2 cube minus 1 cube. Well, so if you think about it, when we talk about last digit, how do we actually find the last digit? Well, first thing to keep in mind is that for last digits over here, it's really essentially a remainder problem. Why? Because this is really the remainder when divided by 10. That is the idea behind this question, right? It is the remainder when we divide by 10. Right, like for example, you have 17. 17 divided by 10 gives you 1, remainder 7. Right, and you notice that, hey, it's not a coincidence. So we are looking for remainders where it's divided by 10. And if you look at this a little bit more carefully, then we can group them up, right? We can group them as pairs, alright? You see that there's kind of one pair over here, There's another pair over here. In total, there is actually 2008 divided by 2, 1004 pairs. Alright? This one might not seem very important at the start, but trust me, it will be very helpful if you take a look at this. So it's very important for you to find pairs. Right? Because it's going to be very helpful later. Alright? Following when we follow up with this. Now, what do I mean by this? Well, as usual, we're going to start small. But how are we going to start small in this case? Well, if you look very carefully over here, one thing is for sure. Now, we can take a look. There are different pairs over here. We can actually start by looking at these particular patterns. Right? 2 cube minus 1 cube. What's the last digit? Alright, we can look at each pair and then we slowly increase its value in hopes that we see a particular pattern that comes out from here. So let's take a look. Alright, 2 cube minus 1 cube. Alright, when divided by 7, alright, when divided by 10, this one is going to give me something. Alright, and it's going to be a remainder of 7. Alright, 2 cube is 8, 1 cube is 1. Alright, so remainder 7. Now let's move on. Alright, doesn't seem very special. Alright, let's move on to 4 cube minus 3 cube divided by 10. What remainder is it going to give us over here? So we know that 4 cube is 64, 3 cube is 27. Alright, so this one is going to give us remainder of 7 as well, right? 64 minus 27. Alright, so far so good. We have remainder 7s. Maybe it is a remainder 7 pattern over here. Now, let's take a look at the next one. So what about 6 cube minus 5 cube? Alright, divide by 10. Alright, 6 cube minus 5 cube. 6 cube 216. 5 cube 125. Subtract the ones place. And you notice that you just get a remainder of 1. It doesn't really matter what numbers I get at the front, alright? I don't really necessarily need to know 216 minus 125, what's the exact answer. I just need to take the ones place, I subtract them away, and I will know that that is the remainder over here. Right? So that is the idea over here that you guys might want to keep in mind about. How about 8 cube minus 7 cube divided by 10. Alright, so we know that 8 cube is just going to be 512, right? And 7 cube is just going to be 343. Right? 512 minus away 343. We can notice that there's a 2 and there's a 3. Now we can kind of carry forward. So 12 minus 3 is going to give us 9. So this one is going to give me something. Remainder 9. Alright, that is essentially the idea for this question. And then what's next? Alright, as usual, 10 cube minus 9 cube. Right, 10 cube 1000. 9 cube we have 729. So in this case over here, we can see 729, 1729, we need to carry forward 1 to subtract away the 9 away, and we'll get a remainder of just 1. Alright, I know it's something, remainder 1. That's what I need to know. Well, we need to move on, alright? There doesn't seem to be any pattern that looks like a pattern over here. So we have to kind of move on. 12 cube minus 11 cube. Alright, well, divided by 10 as usual. Alright, so this is where calculation and remembering cubes is going to be very important. So we have 12 cube, 1728, and we have 11 cube as 1331. So remember, 8 minus 1 is going to give me something, remainder 7. Alright, I do not need to know the something, remember. Alright, so looks like there might be a pattern. Alright, but just to make sure, alright, 14 cube minus 13 cube divided by 10. Alright, what am I going to get? Well, in this case, 14 cube is going to be 2744. Alright, and 13 cube is going to be 2197. Well, 4 minus 7. You top up, 14 minus 7 is going to be 7. So this one is going to be remainder 7. Right, so seems like there's a pattern, right? We have two sevens, maybe, right? We can confirm it if we get a 1 for the next one, right? So in this case, let's try 16 cubed minus 15 cubed divided by 10 over here. Alright, so what about 16 cubed divided minus with 15 cubed? So 16 cubed, 4096, 15 cubed, 3375, right? 6 minus 5, remainder of 1. Hey, can see some particular pattern that is brewing over here, right? It seems to be in groups of 5. Right, the last digit seems to be in groups of 5. We can add all these digits up and we'll get the final answer over here. Now, so in this case over here, there are kind of groups of 5, alright? So you can verify this, alright? There are groups of 5. So in this case over here, we have 1004 pairs, alright? So 1004 divided by 5, there are 200 of these groups with a remainder of 4. So you think about it, these 200 groups over here, when we add all this number up and multiply 200, well, they are definitely going to end with 0 when we divide by 10. So we do not really have to be concerned about these 200 groups. But rather, we need to be very concerned about these 4 groups that are left. Right? These 4 particular groups that are left. And what are these 4 particular groups in this case? Well, we can work a little bit backwards. Alright, we work on this. 2008 cubed minus 2007 cubed. Right, we have 2006 cubed, 2005 cubed, 2004 cubed minus 2003 cubed, 2002 cubed minus 2001 cubed. Right, so we are going to divide them by 10 and we are going to find out what's the remainder. Right, something remainder, something. I don't need to know the something as usual. Right, I don't need to know the something as usual. So in this case over here, let's take a look. There must be some pattern, remember. There must be some particular pattern over here. Now, in this case over here, you notice that there's a 2 over here, right? So that's what we do. So it can be, looking at this pattern, it's going to start with 7. 4 is going to be 7 again. Right? 6 is going to be 1. And 8 is going to be 9. So what about these total values? Alright? You can see that 7 plus 7 plus 1 plus 9 is going to give me 24. So you can immediately conclude that the last digit will be equal to 4. Right? That is the idea behind this question. Right? Very long, very painful, right? And requires you to remember the cubes of numbers. Alright? But one very important thing to keep in mind about is that you do not need to know what are all the blank values over here. Now, all you really need to know, or rather, you do not really need to know is the quotient over here, right? So in this case over here, you just need to figure out what is the remainder. That's the idea. And there are definitely shortcuts to finding these particular remainders over here. Alright, so with that, right, that's pretty much about it for the day. Alright, so thanks everyone. And this is going to be our last NMOS live stream for our book 8. Alright, we are still in the midst of discussion on having more live streams, but not everything is confirmed yet. So, but stay tuned and thanks everyone for coming over. Right, with that, this is Teacher Chiu from Think Academy. Right, you guys actually have children who are actually preparing for the NMOS competition, upcoming NMOS competition on the end of June. Right, do feel free to DM us on how you can actually still how to obtain all these questions over here. While all the redemption is over, I'm sure the marketing will be able to do something about it if there is demand. Alright, so with that, thanks everyone for your time and I will be seeing you guys around. Alright, thank you everyone and have a good night ahead. Alright, bye bye.